Welcome to Tangent Academia. Today we are going to solve a few problems from the chapter complex number, and these are the very easy problems from the very first few theorems that you have learned in the previous classes, in the offline classes specifically. So the question is here: express the following in the form of a plus ib, the standard form of any complex number, which is z equals to a plus ib. You have to express these two expression in the standard format of complex number. Starting with the first problem, here you can clearly say it is 1 by 4 plus 4i whole cube. So you have to express it in the formula a plus b whole cube. So we are going to write it down with the formula a cube plus 3 into a square into b plus 3 into a into bs square plus b cube. You have to remember the few properties of iota, like the I square, I cube, the values of I square, I cube specifically, so that you can put the values of them in here. So 1 by 4, 1 by 64 plus 3 into 1 by 16 into 4i plus 3 into 1 by 4 into 16i square. Here you have to put the value of I square. Hope you all remember it. And here I cube. Now we need the values of I square and I cube. I square equals to, you can write I into I. That will be root over of minus 1 into root over minus 1, which will be ultimately minus 1. And you know I cube equals to, we can write I square into I, and the value of I square equals to minus 1. So we can clearly say this is minus I. So now putting the value of I square and I cube here, 1 by 64 plus 4 4 is 16. So it will be 3i by 4 plus 4 4 is 16. So it will be, and the values of I square equals to minus 1. So it will be plus of minus 12. And I cube equals to minus I, so it will be converted to minus 64i. So let's calculate. First write the constant towards you, or the real part, 1 by 64 minus 12 plus 3i by 4 minus 64 by I. Coming to the next page. After the calculation, you can do in your notebook. We will get 64 and minus 767 after the calculation, plus if we are taking common I, it will be become minus 253 divided by 4. So this is the real part of z, and this is the imaginary part of z. Okay, so we get in the form of a plus I into b, which was our question to express this expression. Now coming to the second part, the second maths. It is 1 minus 2i whole to the power minus 3. We can clearly write down this like this, 1 minus 2i whole cube. Now we have to express it. So we get 1 cube minus 3 1 square into 2i plus 3 into 1 into 2i the whole square, and now minus 2i the whole cube, and it will be 1 divided by 1 minus 3 to the 6i, and here 3 to the 6i square, sorry, it will be 3 into 4i square minus 8i cube. Previously, we have seen I square equals to minus 1 and I cube equals to minus of I. So we are going to put the value of those two, I square and I cube. Here we get 1 minus 6i, and it will be minus 12, and this will be minus plus 8i. So what we get, 1 divided by 1 minus 12, that will be reduced to minus 11 plus 2i. So this is not in the standard format. To make it into the standard format, we're going to multiply it with the minus 11 minus 2i in the numerator and in the denominator also. And in the denominator we got minus 11 plus 2i into minus 11 minus 2i. Now solving this thing, here we get minus 11 whole square minus 2i whole square, so divided by 121 minus of 4i square, which will be minus 11 minus 2i divided by 121 minus plus by it will become I square equals to minus 1, so plus 4 ultimately, which will be minus 11 minus 2i divided by 125. And to put it in the standard format, we have to divide it the two parts by 125. So it will be minus 11 by 125 minus of I into 2 by 125. This is the real part and this is the imaginary part, and it is in the standard format, a plus iv. Welcome to Tangent Academy.